guys, it's Rishi once again, and today we're back with sequences. So what are sequences? Well, firstly, sequences can be linear, quadratic, or practical, which are based on real life situations. Now, we use general rules to help us find terms in sequences. But let's get into this in a little bit more detail. So, once again, number sequences are sets of numbers that follow a pattern or a rule. If the rule is to add or subtract a number each time, then it is called an arithmetic sequence. And if the rule is to multiply or divide by a number each time, it is called a geometric sequence. And each number in a sequence is called a term. Now, a sequence which increases or decreases by the same amount each time is called a linear sequence. And that's where we come into term-to-term rules. So now the term-to-term rule of a sequence describes how to get from one term of the sequence to the other. So let's go through a quick example here. So let's go for the following sequence, which is 3, 7, 11, and 15. Now we need to write down the term-to-term rule and then work out the next two terms in the following sequence. So the first thing I'm going to do is work out the difference in the terms. So I know that it's a +4 every time. So now we know that the sequence is going up by 4 each time. We now can go ahead and find the next term in the sequence, which again will be 19 and 23. So to work out the term-to-term rule, give the starting number of the sequence and then describe the pattern of the numbers. We know the first number is 3 and the term-to-term rule is add 4. Now once the first term and the term-to-term rule are known, all the terms in the sequence can be found. Right, let's go for our second example. So this is where I'm going to have -1, -0.5, 0 and 0.5. So I know that my first term is -1. So again, I can write this down as first term. And if we take a look at the term-to-term rule, we know that it's to simply add 0.5. So again, this is your arithmetic sequence. And there we are. So the next one would be 1 whole and then 1.5. I hope that was clear. So in this video, what are we going to be going through? Well, we'll be going through arithmetic sequences and geometric sequences. Don't forget that sequences can be linear, quadratic, or practical. What we need to do is find the general rules to help find terms in the sequence. Okay, with that in mind, let's get started. Question 1. Here are the 5 first terms of a sequence, and write down the next 2 terms of the sequence. So let's go ahead and calculate the difference. So to get from 2 to 4, we +2, but 4 to 7 is +3, 7 to 11 is +4, and 11 to 16 is +5. So now we know it's going to be incrementing by 1 every time. So 2, 3, 4, and 5. So we could say that it goes up in consecutive numbers. So now we know 16 add 6 is going to be our next mark here, which is 22. And then 22 add 7 is going to be 29. So we can write 22 and 29. I hope that was clear. Let's now move into question number 2. So the first term in the sequence is 3. And the term-to-term rule is add 5. So we need to find out if 97 is a term in our sequence. So let's take a look at this. We start at 3 and we add 5 every time. So we'll have 8, then we'll have 13, we'll have 18, and 23, and so on. So what do we notice here? We notice that all of our numbers end in either 3 or 8. And we know that 97 doesn't have a 3 or 8. So our answer is no. And that is because all the terms in the sequence end in 3 or 8. And there we are. Okay, question 3. We've now got the 5 first terms of a Fibonacci sequence. Write down the next 2 terms in the sequence. So let's understand what a Fibonacci sequence is first. So the Fibonacci sequence is where you add your first and your second number to make your third number. And that repeats in every step. So 1 plus 2 gives us 3. Then we have 2 and 3, which gives us 5. And then we have 3 and 5, which gives us 8. So again, your first and your second number, which gives you your third number. So now we know that we will have 5 and 8, which gives us 13. And then we'll have 8 and 13, which will give us 21. So you can now see how this will go on and on and on. So just to recap, Fibonacci sequences is where you have your first number and your second number, which equals your third number. We will then have your second number and your third number, which equals your fourth number. And this continues. So we start off with the first and the second, now the second and the third, and then the third and the fourth, and so and so. So we can simply write down 13 and 21. Okay, let's go for question 4. So the nth term of a sequence is 4n plus 3. And we need to find the first 2 terms of this sequence. So now we've gone to the nth term. So what is the nth term and what does it mean? Well, the nth term here is where we are then... So if the nth term of a sequence is known, it is possible to work out any number in that sequence. So let's go ahead and take a look at how we would approach this particular question. So for question 4, we know that we need to multiply 4 by the nth number and then add 3. Now n can be anything, and n is going to start from the number 1. So let's go ahead and have 4 and then 1 and then add 3. So we're substituting the value of n into our equation. So we know 4 times 1 is 4, plus 3 is 7. We then take n as 2, and we know 4 times 2 is 8, plus 3 is 11. So you can see that the first 2 terms are 7 and 11. So always remember that your n should start from 1. But if they're asking for, let's say, the 5th term, then again you can substitute 5 into that equation and then calculate the 5th term. And now they say is 35 a term in this sequence. So let's go ahead and try to see if this makes sense. So let's go ahead and say 4n plus 3 equals 35, supposedly. We then make n the subject to see if it's a term in the sequence. So we minus 3 on both sides. So we now know we have 4n equals 35 minus 3, which is 32. And then we divide both sides by 4, so we have n equals 8. So now we know that yes, 35 is a term in the sequence, and in fact, it is the 8th term. And there we are. So again, if you haven't seen our video on making a variable the subject, please watch that video. It should show up at the bottom of your screen now as a link. But if you've already been aware and you understand the process I've taken here, feel free to move on. Okay, question 5. The nth term of a sequence is n squared plus 1. So this is now our quadratic sequence. But worry not, because it is quite simple. As I mentioned previously that n can be any number, and we always start n from 1. Let's go ahead and implement that. So I'm going to substitute 1 in the place of n, and I'm going to square it and add 1. Now what does that mean? That means 1 times 1, which gives you 1, and then we add the 1, which gives us 2. We'll then go ahead and do that with the number 2. So 2 squared is 2 times 2, which is 4, add 1, which gives us 5. So now we know the first 2 terms are going to be 2 and 5. And then again, part B asks us if 35 is a term in this sequence. So how do we do this? We know that n squared plus 1 equals 35. We then take away the 1 from both sides. So we have n squared, which equals 34. But when we make n the subject, we understand that 34 is not a square number. And because it's not a square number, when we square root it, it will not give us a whole number. So now we know the answer is no, and that is because 35 is not one more than a square number. And the reason I say this is because 1 more is written up as n squared plus 1. So that is the reason why I've stated it is not 1 more than a square number. Okay, let's go for question 6. So we've got 5 terms of a sequence and we need to work out the next term. So we know that it's going down by -3 every time. So again, we can go ahead and do the same thing and we can get the next term, which is going to be 2, because 5 take with 3 is 2. And then it states the nth term of a different sequence is 10n squared plus 5. So let's work out the 5th term. Now again, if we're looking at the 5th term, we need to replace n by 5. So let's go ahead and do that. We will have 10, bracket open, 5 squared plus 5. So if we compute it, we'll get 10, and that's 25 plus 5. And if we have 10 times 25, following our Bidmas rule, we have 250 plus 5, which gives us 255. And there we are. So once again, n can be any number, but if they're asking us for a particular nth term, we can go ahead and substitute that value in and get our answer. Okay, question 7. Again, we've got 4 terms of a sequence here, and we need to write down the next term in that sequence. So again, we find the difference between each one here, which again is going to be 6. So now we know the next term is simply going to be 25 plus 6, which gives us 31, and that is our answer. And we have to now explain how we got our answer. And that's because we added 6 onto the previous term. And it's as simple as that. You're doing great so far, so let's keep up the work and let's move on to question 8. Please remember to pause the video at any given time. That way you can attempt the question yourself and then cross-check to see if I've got the same answer. Marvellous. So, we have 4 terms of a number sequence. And the rule to continue the sequence is multiply the previous term by 2 and then subtract 1. So times by 2 and minus 1. So we now need to work out the 5th term of the sequence. So we're going to multiply the previous number by 2, which is going to be 9. So 9 times 2, which is 18. And then we are going to minus it by 1, which gives us 17. And that is our answer. So again, please remember that at given times, at certain points, you may have to break down a question into smaller, more useful parts. Calculate those parts and then put them back together. Marvellous. Question 9. So we've got 5 terms of a Fibonacci sequence. And we need to find the 8th term of this sequence. So we've got the first 5 terms. And we know in order to work out a Fibonacci sequence, we add the first number and the second number to get our third number. So again, 2 plus 2 gives us 4. And now we've got that, we have a new number 1, which is going to be 2 and 4, which gives us 8. But then we can go for 4 and 6, which then gives us 10. And we're going to repeat it just as we did before. So now we're going to go with 6 and 10, which gives us 16. We'll then go with 10 plus 16, which is 26. So I hope you can see I start off with this pair here, and then this pair here. And now I'm going to go with 16 and 26, which then gives me 42. And that is my 8th term, 42. Marvellous work. So now the nth term of a sequence is n squared plus 3. And let's work out the first 3 terms. So we have 1 squared plus 3, 2 squared plus 3, and 3 squared plus 3. And that there would give us 4, 7 and 12. And that is our answer, 4, 7 and 12. Because 1 squared is 1, and if we add 3, that gives us 4. 2 squared is 4, plus 3 is 7. 3 squared is 9, and plus 3 is 12. And there we are. And now it's asking us to find the 10th term. So I'm going to simply take my n squared plus 3 and substitute 10 in that position, calculate it out, and that will be 103. And there we are. So I hope you're becoming more confident on this topic. Remember, it will take time and repetition is key here. Practice makes improvement. So don't let yourself down and keep pushing. Okay, question 11. So now here is a sequence of patterns made from white tiles and grey tiles. So this is more of your problem-solving questions. So in the space below, draw pattern number 4. So let's see what patterns we've got here. So what we're going to do here is count the number of tiles that we have. So in pattern number 1, we have 4 tiles. Pattern number 2, we have 7 tiles. And pattern number 3, we have 10 tiles. So now we know it's adding 3 every time. So let's go ahead and draw pattern number 4. And then as we know, 1 always comes out here. And we can go ahead and shade these in. And that there gives us 13 tiles, because we are adding 3 every time. So 10 plus 3 is 13. And now part B asks to work out the total number of tiles to make pattern number 7. Now we have 4 of the terms already, which is 4, 7, 10 and 13. And we just have to add on 3 every time. So we have 16, 19 and then finally 22, which is pattern number 7. So I hope that wasn't too tricky. Let's then move over to part C. Now Kyle says there are 4 white tiles in pattern number 3, so there will be 8 white tiles in pattern number 6. Is Kyle right? So 4 white tiles in pattern number 3. So there will be 8 white tiles in pattern number 6. Now we know, calculating pattern number 6, we have 19 tiles in total. So if we take a look at this here, we certainly know that Kyle is incorrect. And that is because there will be 7 white tiles in pattern 6. So let's go ahead and calculate this. How did we get 7 white tiles? Well, let's take a look at the way that the white tiles are increasing. So we have 2, then 3, then 4. And as you can see, that's going up in a consecutive fashion. So that's one number after the other. And if we even take a look at pattern 4, we have 5 white tiles. So for pattern number 5, there will be 5. So for pattern number 5, there will be 6 white tiles. And for pattern number 6, there will be 7 white tiles. And that's how I calculated this right away. Okay, and over to question 12. So we've now got a different sequence of patterns made from grey counters. So again, if we add these up right away, we have 5 in the first pattern, 9 in the second, and 13 in the third. So now we need to go ahead and draw pattern number 4. So again, if we take a look at what the difference is for each one, we are adding 4 every time. So we know 13 plus 4 will then be 17. So pattern number 4 will have 17 dots. And there we are. And part B now says work out the total number of counters to make pattern number 10. Well, let's go ahead and list out our sequence, which again is going to be the simplest way possible. So now we know that we have our sequence, and we know that they are going to be going up by 4 every time. And now we know that they're going up by 4, that means it's going to be 4n. And then we need to get the difference between the first term and our difference, which is 4. So 5 take away 4 gives us 1, and that is our sequence. So now we've got our nth term, 4n plus 1. That is our rule that we are going to follow. So let me go through that once more. I have the list of my numbers, and then at step 1, I find out what the difference is. So step 1, find difference. Once I've done that, I then subtract the difference from the first term. So subtract difference from term 1. So now I've gone ahead and done that. I can now substitute pattern number 10 in this. So I'll have 4 times 10, which is 40, plus 1, which is 41, and that is our answer. So this is quite important now, guys. So please pause the video and rewatch this section if you need to. And there will be more questions where we will be going through similar ones. So keep up the great work and let's move on. So question 14. So we've now got the first 5 terms of an arithmetic sequence. Remember, arithmetic sequence is when we're adding or subtracting. And we need to find an expression in terms of n for the nth term of this sequence. So similar to what we've just done in the past question. So we know in order to get from 3 to 1, we plus 4. 1 to 5, we plus 4, and so and so. So we now know it's going to be 4n. So now we know it's 4n, we then have to take the difference between minus 3 and plus 4. So we know if we have minus 3 take away 4, remember we're going for the difference. That's why it's not plus 4, the difference is subtraction. So minus 3 take away 4 gives us minus 7. So now we put this together and we'll get 4n minus 7. And that was our 2-step problem solved. And for part B, it states that the nth term of a different arithmetic sequence is 2n minus 3. And we need to check if 101 is a term in the sequence. So we'll have 2n minus 3 equals 101. We then need to make n the subject. So we'll add 3 on both sides. So we get 2n equals 104. And then we'll divide both sides by 2. So we have n equals 52. So now we know that yes, it is the 52nd term. So we can simply say yes, 101 is a term in the sequence, and that is if n equals 52. So let's go ahead and check this out. So I'll have 2, and I'll substitute 52 and minus 3. So 2 times 52 is 104, minus 3 is 101, and there we are. And that's how you would simply check to see if your answer is correct. Okay, so question 15 and 16, I'm going to hand this over to you. Please go ahead and attempt this question. Don't forget the 2-step method I follow, and then press play when you're ready to go. Wonderful. Question 15. So let's find our difference firstly. And we know that's going to be plus 5 every single time. So we know that's going to be 5n. And then we get our difference between the first term and how much it's increasing by. So 9 take away 5 equals 4. We then put that together and we have 5n plus 4. Similarly to question 16, we'll find the difference of all of these, which is again going to be minus 3. So we now know it's going to be minus 3n. And then we find our difference, which is 25 minus 3. Now we know that 2 negatives give us a positive, so that will give us 28. And we can put that together to get minus 3n plus 28. Great work, guys. Let's move on to question 17. We'll do the same thing now. So we know it's plus 7 every single time, so that's going to be 7n. We'll then get our difference, which is 4 minus 7, giving us minus 3. And we can put that together as 7n minus 3. And we can also take this a step further by checking to see if we're correct. Now we know that our, let's say, 4th term is 25. So I'll simply put 4 in the position of n. And we know 7 times 4 is 28, minus 3 is 25. And that is correct. Great work. Let's go for 18. We'll find our difference, which is 4 here. So we know it's going to be minus 4n. We'll then get the difference. We'll then get the difference between 35 and minus 4. So 35 take away minus 4, which gives us 39. And we can put this together. Brilliant. Okay, 19 and 20. These are final questions, guys. So again, pause the video here, attempt the questions, and then press play when you're ready to go. Okay, so 21 to 27 is plus 6. So we now know it's going to be 6n. We'll then get our difference, which is going to be 21 take away 6, which is then going to be 15. And we can put that together as 6n plus 15. And then the final question. Let's go for our product rule, which is plus 5. So we now know it's 5n. We then get our difference. 2 take away 5 is minus 3. And then we put that together and we have 5n minus 3. And there we are. That brings us to the end of our video. I hope this gave you a good introduction into sequences. Now in this particular video, we've only focused on linear sequences, where we have our arithmetic sequences, which is a term-to-term rule. Just as you can see, we were adding 5 every time, or in question 19, adding 6 every time. So arithmetic sequences are also known as linear sequences, because if you plot the position on a graph, then you will get a linear, which means a straight line graph. And again, we will be diving into straight line graphs soon, so please don't forget to subscribe and share our video. That way you can get updated and notified whenever a new video is uploaded. And once again, just to reiterate, repetition is key. Just like any other topic, you need to do this more than once to get a better understanding. So with that set in mind, make sure you watch this video again, become stronger, comment on the videos if you want me to focus on something different. But other than that, keep up the great work, and I'll see you in the next video.